We're going to start taking a bit more of an in-depth look at sequences, and today we're going to look at subsequences and some theories we can use subsequences for. So we've got xn is a sequence, and then we let ni be a strictly increasing sequence and a strictly increasing sequence just means that n1 m1 is less than n2, less than n3, so on. Right, and the sequence goes from I equals 1 all the way up to infinity. Then, and of natural numbers, so that ni's have to be natural numbers. And then xni is a subsequence of xn. Now, one interesting fact about subsequences is that if xn is convergent, so we know if xn has a real limit as n tends to infinity, so that's equal to some alpha, where alpha is a real number, then this is equal to the limit as I tends to infinity of all xni. So in other words, if xn is convergent, all the subsequences of xn are convergent and converge to the same limit. Now when we take the contrapositive of this, which is when we swap the expression around and then negate it, so we can say if all subsequences do not converge to the same limit, then xn is not convergent. Okay, so that gives us a nice way of proving a sequence doesn't converge. We just have to find two subsequences which converge to different limits. Okay, so if we take an, we'll call it, defined by an is equal to cos n pi, we all know this sequence doesn't converge. This is also a note, this subsequence thing, if we show our subsequence go to different limits, this doesn't mean the sequence diverges, it just means it doesn't converge, well, it doesn't diverge to infinity, sorry. Necessarily, it might do, but as we'll see in this case, that's not true. So, if we define a subsequence a of 2i to be equal, well, that's defined by a of 2i is equal to cos 2i pi, and because 2i is always even, note that I is a natural number here, and you can call this ik. Anyway, the point is 2i is increasing on the natural numbers. Okay, so if you increase I, 2i increases, so this is a subsequence, and note that 2i pi, or 2i is even, and an even multiple of pi, the cos function is always equal to 1, so this sequence is just equal to the constant function 1, so that clearly tends to 1, as I tends to infinity. Okay, now we take a look at a2i plus 1. So this is defined as cos 2i plus 1 multiplied by pi. Okay, again, I is in the natural numbers. Point is here, again, 2i plus 1 is strictly increasing. Increase I, this increases. So for all I, and 2i plus 1 is always odd, and an odd multiple times by pi in the cos function returns negative 1. So this sequence is just minus 1, minus 1, minus 1, tends to minus 1. 1 does not equal minus 1. And therefore the limit as not n, as I tends to infinity of a to the 2i does not equal the limit as I tends to infinity of a to the 2i plus 1, and so an does not converge. Okay, so hopefully this example demonstrates how we can use this fact. We don't tend to use it to show convergence. We might, but you got to think we're not going to check every single subsequence. So this is just generally tends to be used to show that a sequence does not converge. Okay. Hopefully this video was helpful. If you do have any questions about subsequences, then please be sure to let me know in the comments, because in the next couple of videos we're going to be looking at some more in-depth theories, and you'll need to understand this base knowledge. So if you do have any questions, be sure to let me know about that. If you enjoyed the video, please like and subscribe, and I hope to see you in the next one.